So good morning, everyone. So as part of today's session, we'll continue with a few more programs which are related to strings, like working on strings, and then we'll jump back to like some programs which are related to again like non-strings, and then we can have like some more programs related to matrices and all. So during the end of the lecture, we can discuss some more programs if there are any kind of doubts. But for now, let's start with the next program. So next program is also related to a string where we need to determine program to determine if given string is an anagram. So here the only key part is like what is anagram, because most of us don't know what is this anagram. So even though the name is little bit tricky, what it says is, let's say we have a word called as eat, right? And if we reverse this word called as eat, and upon reversing, what it comes is TEA. So what it says is, if my, one second, something is hanged here. One minute, my laptop is just hanged.
Okay. So just stop the recording for a while, or it's not happening.
So, so yeah, coming back to this program, uh, what we want to do is we want to write a program where we want to determine if my given string is an anagram or not. Now, what is the basic definition of anagram? So definition of anagram, it says is if I have a word called as eat, for example, and if I have another word called as tea, like these are like two different words, okay? And if I see here, my both of these words contain same characters, like E is present in both of the words, then A is also present in both of the words, and T is also present in both of the words. So if my first word has like three characters here, and if my second word also has three characters, and same characters are present, but the order of those characters are different, then we say these two words are anagram. So basically, just to give more easiness, right now, if we have this word called as eat, and if we sort these characters by ascending order, what happens is A comes first, then E comes next, and then T. So by increasing order of alphabets, so A comes first, then E comes afterwards, and then T comes later on. Same way for my second word, if I sort these characters inside my word in ascending, I will have as A, then E, and T. So once I sort these two like characters, like these words, I see the output here AET and AET, and these two are equal. So if these two are equal, that means my both of these words are anagrams of each other. So anagram is nothing but like you can create from one word, you can create another word, which is this. So you can have eat as your source word and then tea as your new word. So you can create basically word called as tea from eat by rearranging these words. But that's the definition of anagram. But ideally, what we need to do is to write a program where we will have is like
Yes.
two words.
I want to ask that anagram is same like a palindrome, like
Uh,
input and output value same
no, it's not
from
palindrome.
numbers.
Because for palindrome, how we do is we have is input just one word, or let's say A, B, C, C, B, A. So this for palindrome, we usually have is just single word. And if we reverse this word in palindrome, it comes out to be the same word, which was the original word. So if I reverse this word, I get the same word, which is the original word. And that's why we say like these two words are palindrome, because if I reverse this word, it is the same original word. But in anagram, even if I reverse this word, right, here it's happening that way, like eat is becoming T. If I reverse this, right, eat, it will become TAE. So even though if I reverse this, these are anagrams of each other, but they are not palindromes, because palindrome says like your original word and the new word should be equal. But this eat and TAE is anagram, because the rule of anagram is just two. The first rule is number of characters should be equal. So here we have three characters, and here also we have three characters. So number of characters are same, which are three, and the characters which are present here are distinct characters are three. So you have unique characters like E, A, and T, which are three unique characters. And here also you have three unique characters, E, A, and T. So since my both of the conditions satisfies, like length is same, as well as the unique characters are also present, then I say like this word and my new word are like anagrams of each other. And similarly, it applies for this second word. So as part of anagram, what we'll be doing is we will have like two inputs. Now my two inputs are nothing but this would be my word one called as eat, and my word two will be called as tea. So I need to write a program where I'll take these two inputs, word one and word two, and I will try to determine based on those two conditions if these two words are anagrams of each other or not. So ideally my output should be like a true for anagram, like if they are anagram, and false if they are not anagram. If they are not anagram. So this would be our basic structure of the program. Like what is the requirement? Like requirement is we have two words as input, and as part of output, I just need to display like a message like true or false, or I can have another message like which will be more descriptive, like word one and word two are anagrams of each other. That we can change it in our programming logic. So since we know like in order to determine for two words to be anagram or not, the conditions were first was length length should be same, and second one should be,
Just a little bit zoom the screen, sir.
oh sure,
Yeah, thanks.
this is one. Okay, so my condition for anagram is length of my both word should be same, and number like distinct characters distinct characters between both words are same. So these are like straightforward two rules for an anagram, and in our logic of the program we'll be implementing these two conditions. Now we can collaborate these two conditions into a single condition, which I'll show you in the program. Like we don't even need to write manually like two checks, like two if loops for both of this, right? We just have to do is one loop, which is like more straightforward. So as our like regular programming approach, what we do is we write a program now, like a function for the program. So define anagram, and as part of input, I will take word one and then word two, and then I will give anagram, which is the function call, and then I will have word one comma word two. This is our function call. And before function call, we will declare the both words. So word one is, let's say, eat. Word two is tea. So this creates our structure. Now, let's say we go by the approach of going these two, doing this two condition. So what do we say? Like first condition is if length of my word one is equal to length of my word two. If they both are same, that satisfies my first condition. But what about my second condition? Like how do I know the distinct characters between these two are same or not? So for that we can do is and, which will be my for second one. So now there is one more way of identifying if my distinct characters are same. So the way is we'll sort this word. Okay, so if I sort this word, eat will become by default in ascending order as A E T, right? And my second word also, if I sort it, it will become A E T. So if you see, if I apply sort operation on both of these words, the output I come, the output I get is equal. So basically, I just need to write a sorted of word one, which will sort my word one and get an output like this. And then I'll do the similar kind of operation for my word two and put a equal to comparison between equal to sorted word two. So if these two conditions are satisfied, then what I should do is I should just print true, which was our required format, or we can put some more descriptive information like word one, comma, and word two are anagrams of each other. But if these two conditions, like either one of the condition doesn't satisfy, then we can have is else loop. And in my else loop, I will write the same thing, but the other message like they are not anagrams of each other. Word one and word two are not anagrams of each other. So now let's run the program and see if it is showing the correct expected output or not. Now, ideally, this statement should be printed because these two words are anagrams. So, so if I see eat and tea are anagrams of each other. So that means it is the program is working correctly. If I change my input, like let's say instead of T E A, I'll write T double E. Now here, even though my length of my both words are same, the distinct characters are different because first word has only three distinct characters and second word has only two. So here there is a mismatch in second condition. So in this case, our else loop should be executed. So eat and tea are not anagrams of each other. So this is how this program works. Even though like the name suggests like tricky one, but internal logic also seems to be pretty straightforward. Now,
Yes, so this means the sorted function is playing a crucial role over here.
yes,
With the help of
sorted.
the sorted function only, we are able to find out the anagram.
Yeah, correct. So sorted
Okay.
function was basically taking any word into consideration, like whichever we pass over here, and it will convert that word into an ascending order. Like it will arrange all the alphabets inside it in ascending order. Now, this is one of the way of solving this program. Now here, we don't even need this check of length and it will still work. If we remove this check and if we run it, it will still work. Eat and T are not anagrams. And if I change eat and T, if this should be anagrams now. Eat and T are anagrams also. Now, why that first condition was not required was this sorted function here, as you said, will play like more crucial role. That even though it's sorting, including the sorting, what we are doing is a comparison of the word also. Now, if we just had like, if we sort this, right, eat and t, if we sort and if it is already anagram, then the length is always going to be same. So that is like a implicit, like that is like always we know that whenever we sort the word, its length is going to be same. And if the length is not same, and if we sort it, like let's say we have is just eat and then te only. Now here lengths are not same, and if we sort, now during the sort, what will happen is it will sort like E2 will become AET and TE will become A and E only. Now here, this is not equal, right? Like these two words are not equal. So that is how this sorting function will help. Like we don't even need to utilize the length. But just to let you know what is the definition of anagram, we have implemented that length logic there. If I run this, you'll see they are not anagrams of each other. But if I put A, it should. So that length check was an optional check. Like that's like a good to know if you want to implement the by definition of the anagram. So just in case for now, I will add that check again of length so that everyone is aware like how this function's definition is implemented. So this covers the anagram program. Let me save here. Now the next program also we'll be doing similar for anagrams only, but little bit more advanced on anagrams itself. I think last- Okay, so I'll remove this uh, description from you. Now we'll move on to the next program. Now next program is also similar to this one. The only difference here is instead of letting the output right like true or false, like these two are anagrams of each other or not, what we'll be doing is we will have an input list like this, and it will have like list of words present in it. So let's say we the first word is eat, then second word is tea, then third word is let's say tan, then again we will have one more word called as eight, then NAT, and then BAT. So we have a list of all words present, and as part of my output, what I need to do is I need to group all the anagrams into a single group. Like I basically need to group all the anagrams, like one set of anagrams into one list, then another set of anagram into another list. Now looking at here, We see eat, tea, and ate. These three are anagrams of each other because length is same as well as the unique characters are also same. AET is present in these three words. So how my output should look like is we will have a big parent list like this, and inside this parent list we will have these three words: eat, tea, and then ate. This is my one set of anagrams because these three words are anagrams of each other. Now next one is tan and nat. These two are another set of anagrams because length is same and the characters which are unique are like three and present in both of them. So comma, and then second one is tan, and then nat. And then remains is just bat, which can be only a single group like this, bat. So this should be my output. Now here I see this is my first set of anagram. This is my second set of anagram. And then this is my third set of anagram. Now this is just one of the illustration because my input, we know this list of words, but ideally in real world, we can have like n number of words present in my input list. So based on those n number of words, my output list should also dynamically create. Like we don't need to manually go and check. We need to write a program in such a way that it will work on any type of list. So that list can contain n number of words or zero number of words. It should work. And this grouping of similar anagrams should also be working. So what this program is called as program to group anagrams together for a given list of words. So here it's saying is we have a list of words like this and we need to group it in this fashion so that we have every list inside my parent list, which is one set of anagram and n number of anagrams. So here for this example, we just has three set of anagrams, but it can change and it can have like four or like n number of anagrams, like n sets which are present in this, or like only one set also. So that has to be decided dynamically. So how will we write the program for this? So here the program would be little bit different compared to our previous program because previous program was just doing the definition check, and here we need to do is go word by word and try to add these words into a certain kind of data structure which will help us understand that. So the logic for our program here would be we will utilize dictionary now, which holds value something like key and value format, right? So for this kind of program, we will utilize dictionary data structure, and how we will store is, let's say we take the first word, eat, and once we get the first word, we will sort this word. So now eat becomes, on sorting is AET, right? Now, since this becomes AET, what we'll be doing is this sorted word for eat will become like key. So my dictionary will be like, my key is this, and what should be my value? My value should be the actual word. So my word would be in list and it would be EAT, which is the original word. So this should be my list when I process my first word. Now next word is T. Now once I receive the second word T, Again, what I'll do is I'll sort this word. So eat will become T, sorry, this TEA will become AET. And once we get this sorted word AET, we'll try to check, is this word AET present in our dictionary? If it is present, which is this, so we don't need to create one more entry here like this, but we need to add this word into this list. So this way, my second word would be added here is TEA, because this key of eat and T was same. So I will have one key and these are my multiple values. So if we look closely, we are grouping similar anagrams together into one list. Now let's say we got third word now, tan. Now tan, when we sort in ascending order, what it becomes is A and T. Once we sort, we will try to check, is this key present in my dictionary? It is not present. The only key present is AET. So if it is not present, what we should do is we should add this key here, ANT, and instead of my value, I will get a dictionary here, sorry, a list. And in this list, I will add the original word, which is tan. So this processes my third word. Now fourth word, AET becomes A, 8 becomes AET, 8 becomes AET. Now again, we'll check AET is present in my dictionary. It is present over here. So since it is present, we don't need to create one more entry like this, but we just need to add that corresponding word to my list. And here I will add my next word, 8. And then again, we'll go to NAT. When we sort, again, it becomes ANT. And then we find this key over here in my existing dictionary. So I will just add this word, which is NAT in my dictionary. And the last one is bat. Now bat becomes ATB. This is the sorted. Now here again we'll check ATB is present, not present. So we'll add that entry into our dictionary. It becomes ATB and we will add the corresponding word, which is bat. So this way our dictionary is created. And in this dictionary, if you see closely, all the values which are present on the right hand side are matching up with our expected output over here. So instead of printing this whole dictionary, what we'll do is we'll just print internal values of this dictionary. And that's how we will get the corresponding values. Now, even though this logic seems to be a little bit tricky, it is easy to implement using all the functionalities which are provided by Python. So, okay, so let's do one thing. This session is getting over. We will drop now and we'll rejoin on the new link and then we'll continue the program.
Okay, sir.
Okay,
I'll send you the new link in the group.
yeah, sure.
Okay.